My dear students of Btech second year, I am Dr. Ravin Parsai, Associate Professor of Mathematics and Engineering Science Humanity Department at Chamli Devi Group of Institution Indore. I wish to teach you through lecture 6, Introduction of Interpolation using Newton's forward and backward difference formula with example. So let me review the interpolation first of all. So suppose we are given the following values of y equal to fx for a set of value of x. Now the process of finding the value of y corresponding to any value of x equal to xi between x0 to this range xn is called an interpolation. This is the concept of interpolation. So the technique of estimating the value of a function for any intermediate value of independent variable is called interpolation. So the technique of estimation of the value of a function outside the given range is called extrapolation. And the study of interpolation is based on the concept of differences of a function. So suppose that the function y equal to fx is tabulated for the equally spaced values x equal to x0, x1 equal to x0 plus h, x2 equal to x0 plus 2h up to xn equal to x0 plus nh, giving y equal to y0, y1, y2, y3, yn to determine the values of f of x and f dash of x for some intermediate values of x. We use the following two types of finite differences. Forward difference and the backward difference. So interpolation formulae with equal intervals. First is given by Newton's, so that's why it is called Newton's forward interpolation formulae. Let the function y equal to fx take the value y equal to y1, y0, y1, y2 corresponding the value of x0, x1, x2, x3, xn of x. Suppose it is required to evaluate y equal to fx for x equal to x0 plus ph. P is any real numbers. For any real numbers p, we have defined E such that e raised to p of f of x equal to x0 plus p of h, as by the definition of shifting operators. Or we can say that this is the value is y of p equal to f of x0 plus ph. This can be written as e raised to p of f of x0. So what is the relation between them? So 1 plus delta of p raised to p, because shifting operator and forward difference में relation ये होता है 1 plus delta equal to e. So now through the binomial expansions, when you apply the binomial theorem, you will get this value as 1 plus p of delta plus p into p minus 1 upon factorial 2 of del square, then p into p minus 1 p minus 2 upon factorial 3 delta cube, and so on over y of 0. Applying this inside this, so 1 into y0 is y0 plus p into delta of y0, so p into p minus 1 by 2 of del square of y0, and so on p into p minus 1 p minus 2 upon factorial 3 delta cube of y0, and dot dot dot. In this way you will get this is called Newton's forward interpolation formulae. Now we concentrate over the backward interpolation, that is in which we use the backward difference in place of forward difference using backward difference. Suppose that it is required to evaluate f of x equal to for x equal to xn plus ph, where p is any real numbers. E raised to p of f of x equal to similarly f of xn plus ph. So now y of p or can be written as y of p e raised to p of f of xn. So what is the value of backward difference terms of this? 1 minus delta raised to p of y of n raised to minus 1. So now you can apply again this factorial function for this case, 1 plus p of binomial expansion, this gives to you, and then operate yn inside this yn of p of delta of yn, p into p plus 1 upon 2 of delta 2 of yn, and so on. In this way you are getting this backward difference formula of Newton's. So choice of Newton's interpolation formula. Newton's forward interpolation formula is used for interpolating the values of y near the beginning of a set of tabulated values and the extrapolating values of y a little backward of y0. So Newton's backward interpolation formula is used for interpolating the values of y near the end of the set of tabulated values and also extrapolating values of y a little ahead of yn. So let me come to an example. The table gives the distances in neutral miles of the visible horizon for the given heights in feet above the earth's surface, tabulated as 100 corresponding to this, then 150 corresponding to this, 200 corresponding to this, 250 corresponding to 350 and 400. So here the value of independent value are equispace, so that you can apply forward difference formula or backward difference operator formula. And then the examiner asks you find the value of y when x equal to 218 feet and x equal to 410 feet. So first we prepare the difference tables as we know the process. So first you write the value of independent variable as x, and then you write the value of y as here. Then you can find the difference of this minus this, 150 minus 13.03 minus 10. This gives to you this first difference. Then this is first difference. This minus this minus this minus this minus this. Again you continue for this minus this minus this gives to you this, and this minus this gives to this, 1.48 minus this, then 1.37 minus this, and then for third difference you can find the difference of this minus of this minus this minus this, and then again you can continue as long as you will not get a single difference. Now we take x0 equal to 200, then y0 corresponding to this delta y0 equal to 1.77 from the tables, delta 2, delta cube, delta 4. Since x equal to 218, so step length h equal to 50 and p equal to x minus x0 upon h. This is the formula here, 18 upon 50, that is 0.36. So by Newton's forward interpolation formula you can apply here, and then you can substitute here. First you write the forward interpolation formula y0 plus p of delta y0, p into p minus 1 of factorial 2 delta 2 of y0, delta q of y0, and so on up to delta 4 of y0. Now on substituting these respective values and simplifying this, so this gives to you 15.69741, that is 15.7 nautical miles. Now if we take xn equal to 400 is the last value, yn is the next corresponding yn values, and then yn of del first backward difference having the value 1 plus 37, second backward difference having minus 0.11, third and fourth backward difference. Now you can apply the backward difference formula also here for solving this question. Since x equal to our divine is 410, so step length is h equal to 50 and p equal to x minus xn upon h, so the value is 0.2 as the value of p. By Newton's backward interpolation formula you can apply here, and then you can substitute the respective values here, just simplifying. This gives you 21.53. Thank you very much.